Ladies and gentlemen, good afternoon. This is Jeremy Norvan, and today I want to talk about mathematics and econometrics as the foundations of economic analysis. It is clear to me today that it is almost impossible to do serious, real economic analysis without using mathematical and statistical tools. Some of you, of course, who are listening to this podcast will surely say, "Yeah, but are you going to say that the Austrians are not economists then because they don't use math?" To answer to this inquiry, let me say that there's a reason why the Austrian school is not in the mainstream. First, the Austrians approach economics a from a philosophical aspect. They treat economics as a branch of philosophy. To some extent, their approach is not unwarranted, and the reason why is that economics, specifically classical economics, so that's the era where economic analysis started. It was in fact a branch of philosophy with Adam Smith and David Ricardo and John Stuart Mill. The classical economists were in fact philosophers, and they used to apply philosophical thinking to economic analysis. And the Austrian treat economics as a branch of philosophy because economics fundamentally deals with human behavior. And of course, in the natural science like chemistry or physics, you don't deal with human behavior, you deal with inanimate objects. So the prediction so basically, let me put it that way: the methods of predictions in the natural science are much more accurate than in the social science. And economics is a social science. It is a social science, but a positive science. And the reason why it's a positive science is because economics is the intersection between human behavior and quantities. And anything that is quantifiable is based on mathematical intuition. So when you have consumption, production, income, output, gross domestic product, gross national product, or when you have all these indicators, it tells you that these indicators are testable. It's something that has quantities and that is testable necessitates the application of mathematical methods. That is why mathematics progressively took a huge importance in the methods of economic analysis. Secondly, the Austrians are more focused on the theory itself rather than suggesting practical solutions to economic problems. And in order for them to recommend practical solutions to economic problems, they have to test the theories, because you cannot recommend solutions in economic analysis without having testing your theory. And one of the traditions of methodology in the Austrian school is, of course, praxeology, and praxeology is a priori reasoning. But you cannot use a priori reasoning to test a hypothesis. It's impossible. You need analytical tools, you need math and statistics to test them. And that is why mathematics and statistics have become the foundation of economic analysis, because people want to bring practical solutions to problems. How can we better our world? Of course, Austrians have always criticized the use of mathematical models, saying that those mathematical models are not realistic, they don't deliver the results expected, so they're not reliable. Once again, the point is not entirely wrong, but it is important to understand that mathematical models are simply a simplification of the reality to understand to understand economic dynamics. That's what it is. A mathematical model does not necessarily predict that things will happen the way we think they will happen. They simply predict a likelihood, so a certain probability margin that things could happen. So that is why we heavily started to rely on mathematics and econometrics, because we want to be able to bring practical solutions to real world problems. And the only way to do that is to test the theories that we develop. We cannot use praxeology to test the theories that we develop. Only math and statistics, pardon me, can do those things. That being said, let me now get into the main point of this video, which is to explain how mathematics and statistics are used in economic analysis. As I said, the main purpose is to bring practical solutions to real world problems. And in mathematical models, its purpose is simply to bring us an attempt to solve an issue. And this attempt must be testable. That's why we create mathematical models. So for those who want to become economists, but they have one problem, the math. I know many people who truly want to do economic analysis, but they're afraid of the math. They say, how can I want to do economics, but I'm afraid of the math. I don't know math. I don't know anything. Let me here give my own experience. So when I started getting to economics, I was applying the Austrian approach. So Austrians, they think like lawyers when they do economics, because the law is technically the most analytical uh, aspect of the social science, should I say, and specifically of anything that is qualitative. It's a qualitative approach to evidence, to think logically and rationally. So that's how Austrians do, and I used to apply their thinking process to economic analysis. But I realized that although that method was good to develop a theoretical structure, it wasn't good to test it, because I had no ways to test my theory, so I wouldn't know if what I believe to be true is necessarily valid and how it could solve this potential problem that I was seeking to solve. So I decided to get into the math. And one thing that economists have been mystified people about is that they make economics seems that when you develop a mathematical model, it must be a super complicated, super advanced model. That's completely false. When you develop a mathematical model, first of all, a mathematical model is simply based on what you're trying to test. It depends on the magnitude of the problem you're trying to solve. If the problem you're trying to solve is relatively simple, there's no need to use overcomplicated methods. There's no need to use method of calculus 3, or I don't know. It depends on the method, on the problem you're trying to solve. A mathematical model start basically at algebra 1. It can start from algebra 1 all the way to multivariate calculus and other branches of economics. As I said, everything depends on what you're trying to solve. But in economics, the mathematical method we use are generally the following. You use calculus 1, 2, and 3. You use linear algebra. You use topological methods, and you use real analysis. So, for instance, when you get to deal with collective choices, then here what you're going to use is topological methods, because topological methods are based on sets. So you're trying to see how the decision of one may affect the outcome for others. So that's why topology is it becomes crucial in economic analysis. When you're dealing with marginal production, marginal labor supply, and stuff like that, usually you use method of calculus 1, such as derivative, the chain rule, and stuff like that, and integration. sometimes differential equations. It depends. But these you use method of calculus 1 and calculus 2, sometimes calculus 3. And when it comes to demand and supply, and you want to see how the input in one economic sector affect the output of the other economic sector, then you use linear algebra, also known as input-output analysis. In fact, this method was first developed by François Quesnay, which was a French economist, but it became really famous through Vassily Leontiev, who won the Nobel Prize in 1973 for extensively developing that model. So you use that, and real analysis is basically used jointly with linear programming for optimization problems. So when, for instance, you work in industrial organizations, specifically in consulting, and the business is trying to see how they could optimize their performance, you are basically going to apply linear programming in order to determine in the future how their performance could be optimized and what would be the outcome of the model. So that is why we use mathematics in economics. We use it for these specific purposes because in economics we're driven by incentive. So we're always trying to maximize, to minimize. We're always trying to understand people's choice, their interactions, one how the decision of one will affect the result on the other. And we apply game theory too, like which is the mathematics of interactions, game theory. So these are the methods that we use in economic analysis. And as I said at first, the purpose of using mathematical methods is to test them. And you can only test a mathematical model through the application of statistical techniques. That's why econometrics is also part of the foundation of economic analysis. So econometrics, as you guys know, is the application of statistical methods to economic theory. So you have a theory. Let me take, for instance, the famous consumption function of John Maynard Keynes, which is a mathematical model which states that consumption increase based on the level of disposable income. So consumption is the outcome variable. Then you have the autonomous consumption, which is the fixed parameter. Then you have the marginal propensity to consume, which is the coefficient. And then you have the disposable income, which is the independent variable. And then econometricians put the epsilon after the equation. And the reason why they put the epsilon after the equation is to minimize the errors while testing the model. That's why. So Keynes developed this method, but we wanted to make sure it is valid. So if a country wants to understand how its people are consuming, they're going to test the disposable income of the population against its consumption to see how much they consume. So we know that the more the more your disposable income increase, consequently, the likelihood that you will consume will be higher as well. So econometrics here enables us to test theories so that based on the results of those statistical models, we can now deliver practical solutions to real world problems. That is why for someone who wants to learn econometrics, for someone who wants to do serious economic analysis, he or she has to apply econometrics. And Once I started learning math, I saw that it was relatively easy for me to get into econometrics because it was a logical continuation of mathematics and statistics. And and as I said, like when I got into economics, I used to apply a very qualitative approach to economic analysis, but I had to test my theories. So that's when I started learning math and econometrics so that I could be able to test what I believe to be true. If it's true, good for me. It means that my model stands and my theory is valid. If it's not, I have to refine my assumption and retest the model again and see if it's valid or not. So in this 21st century, ladies and gentlemen, it is almost impossible to do serious economic analysis, and for your analysis to be recognized by your peers, it has to incorporate mathematics and statistics. It is crucial. Today we have a wide variety of data sets. Indexes are created all the time. So we have new data available and we can test economic variables. We can even test political variables. I am even in favor of the application of mathematical methods and statistical techniques in political science too. I think it is important that we incorporate more mathematical methods in the social science because at the end of the day, a social science is not a humanity. A social science is a science that focuses on human behavior. And human behavior could be predicted to some extent, I believe. As I said, I don't think you can predict human behavior 100%, but it is predictable to some extent. So I reject the Austrian view when they say that you cannot predict human behavior. I don't necessarily agree with that. I think you can predict it to some extent. So uh, it is important for you to therefore start learning mathematical methods and statistical techniques. So now, what are the recommendations can I give you for you to put your skills, your math skills up to date if you want to do economic analysis? So if you have absolutely zero, when I say zero, it's like you have really bad math skills, like you don't know math at all. Start with algebra 1 to get all the foundations. Start with algebra 1, then move to algebra 2, then move to pre-calculus. So these three will give you a really solid foundation. It will develop your analytical thinking when it comes to apply mathematical methods to economic theory. And then once you have done these three, now you can move to calculus 1 and then calculus 2, calculus 3. If you're someone who loves to deal with with collective choices, maybe you want to get into topology. If you rather deal with maxima, minima, constraint optimization and stuff like that, maybe you want to do linear programming. And if you like the equilibrium analysis of supply demand, then you want to get into linear algebra. But yeah, so start with algebra 1 if you have zero knowledge of math, if you have zero skills in mathematics. Algebra 1 it's literally the basic. And what are the platforms where you can do that? So Khan Academy to me is the best platform. That's where I put my math skills up to date. I started with pre-calculus and then I move up to calculus 2. I have to get into calculus 3 soon. So as you see, I'm not done yet even on my math part. Like I'm still learning. But I have to say that since I've been doing that, my math skills have tremendously increased over time. And doing mathematics becomes a second nature to me. So if it became a second nature to me, it can become a second nature to you too. But it's something you have to do it every day. If you don't do it every day, you won't be good at it. You have to do it every day. Mathematics is like doing math is like driving. The more you drive, the better you become of a driver. The more math you do, the better you become good at it. So it's a matter of practice. You have to keep doing mathematical exercise every day. If you can do it for an hour or two, you keep doing that every day, you will see that your thinking process will drastically change. You will start thinking really fast. You start thinking things, seeing things that you used to not see. So it is very important to get your math skills up to date. And then when it comes to econometrics, what you need to know is that in econometrics, don't get intimidated by the thing itself. Yes, econometrics is not an easy field, but at the same time, it is learnable. And what you really need to know about econometrics is that you don't need to know all the techniques. Again, everything depends on the problem you're trying to solve. If the okay, so the difficult part in econometrics is Bayesian econometrics, which deals with a lot of uncertainties and probability theory. And this part of econometrics is mainly used in finance because it is sometimes hard to predict the market. So quantitative analysts use Bayesian econometrics to predict the stock market. But if you work in marketing or business, usually what you need to know is how to apply the linear regression, how to apply the logistic regression, and how to use the various regression models in time series. These are what you need to know in econometrics. Based on econometrics, I'm not saying don't learn, you can learn, but it is not a prerequisite to do econometrics. Bayesian econometrics is a very advanced uh, method to it's a very advanced method of application, if I can put it that way. It's very advanced, and it's only for very sophisticated problems that we use that. But for someone who works in marketing, who use analytical tools, usually the linear regression, so simple and multiple linear regression, the polynomial regression, the exponential regression, the logistic regression, the logarithmic regression. So these are the tools that you use. But those ones are kind of simple. But this is what you have to use. And again, everything depends on the data you have in front of you. So don't think that the linear regression is applicable in every situation. No. The linear regression is, of course, the model that you start with because it is the most basic statistical model that is used pretty much everywhere. But you don't use it in every situation. You start with it to see if the model fits. If it doesn't fit, then you switch. But even before that, you can even look at the trend of the data and you can tell already if the linear regression is applicable or not. So if you want to learn econometrics, you can. There are many YouTube tutorials. I even made some tutorials on YouTube myself where you can learn the basics specifically for the linear regression. So yeah, that's what you need to know. You need to know the basic regressions and how to analyze time series data, and you should be good to do economic analysis. So yeah, it's really doable. Just don't let mathematics and econometrics intimidate you. Those things are doable. You just need the discipline to do it. And I have to say this, guys, if you really want to be considered an economist, even though you don't have a degree in economics, if you want people to take you seriously as an economist, you have to do those things because you have to be able to analyze economic data. You have to be able to do economic forecasting. Yes, you don't have a degree. You don't need to go spend $50,000 on tuition just to get a degree in economics. You can even create a blog or a vlog where you show your work. But I think the best way to become an economist without a degree, in my opinion, is to write books on economic issues. Because if you do that, and that's what Adam Smith did. See how funny that is. Adam Smith, who is the father of modern economics, the father of classical economics, was a philosopher. He was a philosopher and he wrote two books in his life. The first was The Theory of Moral Sentiment, which was a book of moral philosophy. And the second was The Wealth of Nation, which was a book of economics. And Adam Smith is considered an economist, although he never had a degree in economics. He just wrote that book, that one book. That's all he read. All he wrote, and he's an economist. So to me, that is the best way. Write a book, you can publish it on Amazon. Today, with Amazon's self-publishing platform, you can write your book and publish it. And technically, you are an economist. But also write papers, write scientific papers, I mean, publish them on research papers in economics, uh, social science, network research, and academia.edu and ResearchGate. Those are big platforms where scientists interact all the time. They post their papers there and they exchange ideas. They give feedback to one another. So if you want to be considered an economist, these are the stuff you have to do. You have to produce. You have to write books. You have to write papers, and also trying to be part of some economic organizations and try to go to those conferences you're part of so that you can expose your work and people can see. And that's how you become an economist. It is doable. It is doable. If you can also publish with a journal, with a professional journal, do so. But I have to say, guys, it's very difficult. I was able to publish with a journal, but I have to tell you the process is really not easy, and you will get more rejections than anything else. It is very difficult. You have to be resilient. If you if you're adamant about publishing with a journal, you have to be resilient because the amount of rejections that you're going to get is paramount. You will be discouraged at some point, so you have to hold tight. All right, ladies and gentlemen, that was my point of the day regarding mathematics and econometrics as the foundations of economic analysis. So yes, guys, so learn math, learn economics, and you're pretty much set to go to become an economist for real. Because in this 21st century, if you don't use math and econometrics in your analysis, you will not be recognized by everybody. You won't be legitimate in the profession. You have to be able to use those tools if you want to ascertain your legitimacy as an economist. So let me know in the comments what you guys think. I was glad to talk about this. And until then, see you soon, guys. We will see later what videos I can make on what subject, but it will surely be about economics again. All right, see you guys.